This module covers browser forensic. I will focus on Edge as built-in browser. Internally, Edge is based on Chrome, or in Chromium to be precise right now. So some things may be somehow similar, some things may be a bit harder. If someone is using Chrome, it should be even easier because if particular technique works for Chrome, for Edge, it will work for Chrome as well. For other browsers, well, we have some comparable utilities. I will rely here mostly on Nearsoft tool. When it comes to the data being stored by the browser, for the Edge it is quite deeply hidden under AppData local Microsoft Edge user data. If we have multiple profiles, please do remember within browser we can have under settings, we can have profiles, we can have a lot of profiles. Every single profile has a separate storage for its stuff, starting from passwords to temporary files, etc., etc. So we should browse all profiles when trying to figure out what is going within the browser. Under the default profile, there is a cache folder, and within cache, there is a cache data. And here, right now, happens like a typical cache. Cache may be useful just to verify which files user addressed. However, we have only a part of the context here. I will start with the image cache viewer tool from Chrome, and here you can see the location is not this one. This is from Internet Explorer cache actually. And it is not that interesting. I would like to see the content of the Edge cache data. So Control C, and here under Options, Advanced Options, I can specify the particular folder. Control V. Okay, and now this folder is scanned, and I can take a look into some image files. Hopefully some of those will appear on screen. I can try to figure out what user saw on the screen and from which site this file went. So some images from Google, some images from MSN or even Bing, some images from Nearsoft, I believe, as I went to Nearsoft to download those tools, etc., etc. So we can try to figure out what user had a chance. There's probably some ad on some of web pages, etc. We can figure out what we have in this cache, or you can simply copy this file if you do not want to rely on the third-party tool. I will pick a random one. Hopefully it will work. I will try to open it with Notepad just for the verification. No idea what the format is. In typical examples, so let's start with another one. This one is big. I will copy it to desktop to have a copy. I will open it with Notepad. I promise this last try. Again, no idea about the format. Well, image cache viewer is able to determine the format and to open the file. In most cases, if you figure out what format it is enough to put it right file extension. So it is why determining file format may be useful. It is art on its own. It is not the topic of this module with this course for sure. Anyway, we have the cached data here, but we have also couple of other things, as browser is trying to help us when we browse the internet. It will try to provide us history, the search history, the visited places, visited web pages history. If you press Ctrl J, you will see the list of the history of downloads. So it must be stored somewhere. If you dig through other tools, this is a browser downloads. You can clearly see what file was downloaded. Quite useful for the forensic analytics. So DBG view from livesysinternals.com, and we have timings and some details, and also I have information where did this file went. So it went to downloads folder, which is not the big surprise. It turns out to be true. And for other things, I can see the history of the browser. Nearsoft tools are okay for this purpose because they are aware of different browsers. Here you can see there's a history browser nose, and it, as you can see under web browser, it is trying to scan different browsers, trying to help us somehow identifying which one it was and which one user actually is using. It may be like a portable application, etc. If we know where to look for this data, we'll identify the data and we can extract the history. Of course, it is not extracting the in private mode browsing because history for this one is not being saved. But for in private browsing, files may be temporarily stored on the drive and should be automatically removed when you close the browser. So maybe some traces, especially in the journal, can help us, but there is nothing stored for the future use within the database. So if we do not like to have in private browsing in the organization, we can simply block it as it is manageable in practice. However, I believe it is like making life harder and not protecting anything in practice. This one is interesting. However, this one works for Chrome only, and Chrome changed this significantly because browser can try to help us with password, can automatically fill up the password. I believe this feature is great, but it means browser must know this password. So if browser knows it, the third-party application may know it as well. It is protected by the end-user password. So actually knowing an end-user password is important, or in an Active Directory, some very specific Active Directory backup key for the DP API under some conditions. But anyway, if we use password storage for a browser, which is still better than keeping them in Notepad or all passwords in your head, it can be read. Using some tools, you should be aware of this, but it requires the same user. This one will not run against Chrome, against Chromium-based Edge. It is designed for work for Chrome. In the past, passwords were simply stored, protected with DP API in the SQLite database. I even have a script extracting passwords for Edge and Chrome on my GitHub, but right now it was modified a couple of years ago, not so long time ago, but it is not like absolute news. Old tools are not capable of extracting this data. The next tool allowing you to do some forensic analytics may be related to cookies. Again, providing you some information, maybe not directly about pages visited, because it is about all the stuff being linked to for the web pages. But it may give you kind of an overall idea. For example, I never visited LinkedIn from this page, but I believe LinkedIn frame or something or script was referred from one of other web pages, maybe from MSN or whatever. And it is why it appears on the list. Here you can mostly see something user sets on purpose, and something valuable may be a result of a time analysis when it happens that the particular cookie appeared here. So it means the user browsed through something somehow related, even loosely. But as I have said, it may be against user will to have something here, because if you go somewhere, the scripts are working, frames are loaded, etc. So it does not mean user visited LinkedIn. You should not rely on this in such way. So please be aware that browser is trying to collect the data for making loading web pages faster, namely a cache, which will be in different places for different browsers and different browser profiles. And browser saves data, allowing us to have a better experience when browsing web pages, filling up fields with address, credit card number, passwords. We have cookies, we have history of downloads, we have history of visited pages, history of searches. Everything is stored within browser databases, and we can have different browsers with different profiles each, so it is like endless rabbit hole. Digging through it is a fun of its own, and it's huge area for interesting forensic activities.